to be very similar to simplifying. And always still with our mantra with this unit. What are we always doing first, everybody?
Factor.
You got it. So factor first, always and forever. And then after that, we'll simplify, just like with simplifying. The only thing that'll be different than kind of with simplifying when we started thinking about that when our graphing is we're going to have to say restrictions on our domains. And remember, restrictions with your domain is going to happen anytime your function's undefined. When is your function undefined? Yeah, that could be a situation. And why does a vertical asymptote happen? What do you think, Mithra? Awesome. That is it. When your denominator is equal to 0. So take a moment and jot down a question 1. And then how are we getting started with question 1? What are we doing first, McKenna? There we go. Factor first. So take a minute to also factor all of these expressions. All right, you guys. So looking at our first fraction, anybody find the factors for the numerator? What did you find, Yalda? All right, what about the factors for our denominator? What would that x squared minus 9 factor into?
X minus 3x plus 4.
Great job, Evan. So now that we're here, if you remember thinking about where we might be going next, if I had this, talking about multiplying fractions. So if I have 4 over 5 times 15 over 2, how do I multiply fractions together again? Multiply what, Evan? Oh, that's if you're adding and subtracting common denominator. I just multiply, meaning I'll multiply what and what together. Numerator and numerator, and then denominator and denominator, right? So think about if we were to do that here, that would get kind of crazy. Multiplying all of this numerator times all of this numerator, all of this denominator times all of this denominator. So what's going to be much easier for us is if you think about 4. If you were to break that down into 2 times 2, and 15 into 5 times 3, because 5 and 2 you kind of can't break down anymore because they're prime. Now do you see how you can actually simplify first? And it'll make your problem much easier. So think about, I can divide by a factor of 2 over 2, and by a factor of 5 over 5, because it's that common in the numerator and denominator. So you would be left over with like just 6, right? So thinking about from here, if you're going to simplify this expression, I can simplify anything across my numerator and denominator as long as they have a common factor. So it doesn't have to be from the same fraction, right? It can be across both fractions as long as you're dividing by a common factor in the numerator and denominator. So what common factors do you guys see to simplify by? What's one you see, Yalda?
X minus 3 and x minus 3.
Right, x minus 3 over x minus 3. Do we have anything else? X plus 3 does work because I have an x plus 3 in a numerator and an x plus 3 in the denominator. Kind of like how I have 2 over 2 here. What else do you guys see? What else do you see, Mithra? Yes, we have an x divided by an x, which is still something divided by itself. So what are we left over with? In the numerator, we only have 3x plus 4 left over. And in the denominator, we only have the number 3 left over. So that's what that function is going to simplify to after we multiply. So if you remember with multiplying, now we're going to also have to state restrictions, meaning what values can x not be? Because these would have made the function undefined. Yeah, so y'all just already starting it off. How did you know 3 and negative 3?
Because x minus 3 and x plus 3.
Great job. That first fraction, 3 and negative 3 would have made that first fraction denominator 0. What other values would have made the second fraction have a denominator 0?
1.
Not quite 1. Think about, it would be this factor 3x. What would make that 0? If x was 0. Still I'll have 3, -3, and 0. So that's going to be part of your answer here. You'll have what you simplified to, and then what are those values that x cannot be for my function to be defined. And that's going to be like a new thing for us moving forward. Anytime you're working on a problem, you're always going to have to state restrictions too. What other questions do you guys have here? All right, so process, factor first, simplify, state restrictions. Let's check out second example. Give you guys a moment to jot down our second example, and then how do you get started? Factor. All right, let's see what you guys found for those factors. Somebody want to tell us, what did they find the first fraction numerator to factor into? What did you see, Alda?
X plus 2.
Great. What about the first fraction's denominator?
-2.
Uh-huh. Great. What about the second fraction, that numerator? What were those factors? Somebody that has not spoken yet today, what do you guys see? Think about your A's, ones, you're just looking what multiplies to -7 and adds to -6.
What's 1 times x minus 7?
Good job. All right, and then lastly, the second fraction's denominator. What do those factors become?
+1 plus 5.
Good. So x plus 1 and x plus 5. All right, and what do you guys notice now that you're here? Yeah, now the fun really starts to happen, right? What do you guys see we can simplify by? Ooh, okay, we see an x plus 5 in a numerator, an x plus 5 in a denominator. What else do we have?
-7.
Ooh, yeah, an x minus 7 and an x minus 7.
X plus 1.
Cool, x plus 1 over x plus 1. Anything else? No, right? Because x plus 2 and x minus 2 are different factors. So this is all going to simplify to just x plus 2 over x minus 2. And are we done with our problem? No, we still have to state those restrictions. So what values can x not be? So let's go from the left to the right with our first fraction. What's our first value x can't be? 2, and then x can't be 7, because those would make those those factors 0. And then in our second fraction, what value can x not be? -1 and -5. There we go. Alright, so we're going to now get into dividing fractions next. Before we do that, that's going to really build off of our skills with multiplying. What questions do you guys have with multiplying before we get there? Yeah, Morgan?
Can you just show how you got the limitations on these?
Yep, it's anytime your factors would become 0. So going from the left to the right, looking at your first fraction, right? What value would make that 0?
2.
Boom. What value would have made this 0?
7.
All right, 2, 7. What value would have made this factor 0?
-1 and then -5.
That's
Is
it.
it just on the denominator?
Yes, with multiplying. So this is going to bring us to kind of how dividing can get a little different, a little spicier. So with multiplying, just think about your denominator, right? Because it's any time it makes a denominator 0. So let's get into multiplying. Before we do that, how is division different than, or how do I divide if it's just a fraction? Right, if I have one fraction divided by another fraction, what's that process? What do you guys remember about dividing two fractions? Multiplied by the reciprocal, that's going to be our same process here, so keep that foundation in mind. we're still going to multiply by the reciprocal, which means we keep our first fraction, we change our division to multiplication, and then we flip it so that fraction becomes reciprocal. Yeah. So this is multiplying by the reciprocal. Keep, change, flip. So changing that division to multiplication, then flipping our fraction. So then it's the same process all over again. So we are going to have to state restrictions to our domain. Any time a value could make a denominator 0. And now we'll kind of get into that with our example. So looking at example 3, if I'm dividing, what's my process for dividing? Two fractions. What are we thinking about? Before I factor, how do I just divide in general? I flip it, and I have to change my division to. Good. So the problem I'm really doing is I'm keeping my first fraction, which is x squared minus 2x minus 3 over x plus 1. I'm going to change division to what symbol again? Great. So that's my change. And then I'm going to flip my fraction to become now x squared plus 4x over x squared plus x minus 12. Now, does this look like a multiplication problem we could do? Yeah, it does. And how are we going to start with that multiplication problem? Factor. So why don't you guys take 2 minutes and factor from here. How you guys factor these? So what about our first fraction, that numerator? What are those factors there? What did you guys find for that first fraction's numerator? Great job. X minus 3 and x plus 1. And then our denominator is going to stay x plus 1. That second fraction is going to factor into x times x plus 4. What about the denominator? What would that denominator factor into? Math. What do you see, Laura?
X minus 3x plus 4.
Great job. Okay, now here, let's start with the fun. What do you guys see? Simplify by.
Everything but
Yeah, so specifically, Morgan, what's one factor you see?
x plus 1 and x plus 1.
Right, I have x plus 1 over x plus 1. And then what other factors?
X plus 4, x plus 4.
Great job, another x plus 4 and x plus 4. And then we can also keep going and do my x minus 3 over x minus 3. Think about one for a numerator and one for a denominator. That's the only time you can simplify by. So Morgan was letting us know everything's going to simplify but x, which is so fun. Just kind of seeing that only x is going to be the product of after you would multiply all those together. So from here, let's state those restrictions. And we're going to kind of start off with what we know, right? Looking at the first fraction, what value can x not be?
Negative 1.
-1. So think about x plus 1. Right there, I don't want that to be 0. So that means x cannot be -1. Now let's look at our second fraction. Yeah, how are you getting 3 -4, Aldrich?
3 would make 0 or -4.
Great job, and that's in that second fraction's denominator. But remember, we have to, so everybody, this is the part that can get a little confusing. We have to state restrictions on any time you would have a denominator become 0. So thinking about from the beginning of our problem, we stated a restriction here for -1, and we stated a restriction for here because that's us in that second fraction after we flipped it to make it a denominator. But looking at your original problem, would you agree x squared plus 4x is also a denominator right here?
Yes.
Yes. So therefore, I also have to keep stating restrictions for that part as well, which means we have to add what other value to our list? So think about, we already have -4, because -4 plus 4 would become 0. So my other factor would be from x, which means x can't be what number? 0. So basically, what you need to know from the beginning of your problem, everywhere that I'm putting a blue box around, you have to state restrictions. And everywhere that I'm circling in green, you don't. So that first fraction numerator is safe. Everywhere else has to have restrictions stated. Another way you might look at this is thinking about this operation is division. Another way you could express division that we're going to get into maybe I think at the beginning of next week would be to think about this as being a fraction over another fraction. So basically, if you have that idea in mind, this whole second fraction is always in a denominator if you set it up like this. So that's kind of why that whole second fraction has to get those restrictions stated. Morgan, did you have a different question?
Yeah, I was gonna ask, like, how did you determine that x could be 0 from?
X can't
Or
be
yes,
0.
yeah.
Okay, so just to what we were just saying. So you saw how we factored this, right? So think about, where did this factor come from? It came from us factoring x squared plus 4x. You see how in my original problem that's in a denominator?
Yes.
So therefore we have to say restrictions on it.
That makes sense, but like, I just don't understand how you got 0 as the restriction.
Because x is the factor, right? What value would make x 0? 0.
Got it. Okay.
So if you're ever stuck like that, just think about set the factor equal to 0, because that's what you don't want, right? I don't want that value to be 0. So you're kind of solving from x from there to figure out what value would make that 0. What other questions do you guys have? Henry? Yeah. All right, guys, looking at example 4, we have another division problem, which means what's our setup for division? Yep, multiply by the reciprocal. So let's start it up, and then what should we do to get started? How do we get started after we set it up?
Factor.
There we go. Let's get started. All right, guys, so let's factor and see what we find. What will our first fraction's numerator factor into?
X plus 2. X plus 2.
X plus 2 and x plus 2. What about our first fraction's denominator? What did you guys find that to factor into? Did anybody find it to be x squared minus 4 and then x plus 3?
Oh, yes.
Oh, yes.
Oh, yes.
But what do we know about x squared minus 4? I can factor in 4, so let's keep going. Because remember, for us to be able to simplify, we have to factor completely, which means we have to factor all the way with each expression. Which brings us to our second fraction. That numerator would factor into x times x plus 3. And what about our denominator? We have a GCF of x, and then what were the other factors? What are those other factors?
Minus 4.
Uh-huh.
And x, yeah, x plus 2.
Okay, so what are we looking for now that we're here? What do we see? The things. What are some things we see?
X plus 2, x plus 2.
Oh, yeah, common factor of x plus 2 over x plus 2. What other?
X plus 2 again.
Yeah, x plus 2 and over another x plus 2.
There's 2 x's.
Yes, there's an x over an x. Yes, x plus 3 and then x plus 3 over here. So nothing's left in my numerator, which means what value?
1.
1. Yeah. Always remember. And then what's left over is x minus 2 and x minus 4. And are we done with our problem? No, what do we still have to state? Find the things x can be, which means those are restrictions. What values can x not be? Looking at our first fraction, what are those values? -2, 2 and -3. Good start, guys. And let's look at our second fraction. And what values can x not be here? Yeah, so x can't be, so what have we covered so far? These 3, and then here all will be 0. And then what other do we need to add to the group?
4.
Yep, 4 from here. And we already have -2 covered from here. And is that the only other place I need to check? No, I also need to check this numerator as well because it was once upon a time in the denominator, which means my x can be 0, which do I already have 0? And -3, do I already have -3? Cool, I forgot to write 4, didn't I? Then, that's it. We got everybody covered. So don't forget, kind of think about everywhere I underlined in blue is where we have to state our restrictions for division. All right, what other questions do you guys have? All right, I'm going to give you guys one question to try on your own. So you guys thinking about trying this? Oh my gosh, don't be scared, right? Multiplying these 2, and then what does this division mean we would have to do?
More steps.
Yeah, more steps. Multiply by the reciprocal here, which would just look like
Excuse me, Sabina. Could you please give me more?
multiplying by x squared plus 15x over 2x squared plus 5x. And then, what's we were in factor for? What did you guys see we could keep simplifying by? Anybody see any common factors in the numerator and denominator? Do we have any common factors? Nothing? We can't simplify it all? Is that what we did? We just didn't simplify it all?
I told you this problem was bad.
No, we can keep simplifying. There's some fun to be had. Let me see.
Plus 15.
Yeah, I see x plus 15 over x plus 15. Someone said x over x. What else do we have? Nothing else? Yes, x minus 2 over x minus 2. And then do we have anything left in there? No, because just think about those signs don't quite match up. So you would have had 3, x plus 3, 2x minus 5 left in your numerator. And in your denominator, you have 2 times x minus 3. Now we're not quite done. What values can x not be? So with your first fraction, what values could x not be? Minus 15 and 2. What other values with my second fraction can x not be? 3. And then with my third fraction, what values can x not be? What values can x not be with this third fraction? First up, it can't be 0. Are you okay there? And what other values can it not be? -5 over 2. And then I'd also want to check this numerator, but we already have 0 and -15 covered. So we are good to go there. What other questions do you guys have from multiplying and dividing today? You have a new Delta Math homework that's posted starting today with our operation. So next time we're going to do addition and subtraction. So if I were you before next class, start looking at that Delta Math homework. Go ahead and get started on it. I passed back your Unit 5 test. If you know you want to retake that test, you can also go ahead and get started on that process too.